So we are going to use this function, print accuracy, to measure our machine learning model accuracy with different metrics. Okay, so for example, here the first machine learning example we can use is a random forest. We import the random forest and create a classifier from the random forest and fit our test set and training set on it, and then print the accuracy. When on printing the accuracy, we found this is the number of, okay, natural. This is the actual results here, the actual records, and this is the predicted records. Okay, so whenever you have darker results, means it's less. You have less or negative values or non-true values. Okay, whenever you have any lighter results is more it's more valid results, and valid machine learning results. So for example, the precision here, it's about the accuracy is about overall accuracy score is about 72%. 72% is overall. Okay, the precision is 74 for positive, recall is 94 for positive, and F1 score, it's a mix or average score between the recall and precision. It's around 83. Okay, so um, we have here, for example, all classifier, all positive value, and classified true as positive value, and recall all negative value or positive value classified false as prediction value. So the accuracy score for neutral, for example, it's misclassifying many positive values here. There are a lot of errors in neutral predictions. So overall prediction for neutral is F1 score. Maybe we need to add some data to mix or more data to our machine learning models or machine learning data itself. And also here we used naive Bayes. Naive Bayes, it's a different, also it's a classification model also we can use. Okay, and we can find the accuracy score, it's around 67, which lower than the accuracy we got from random forest. For random forest we have 72. We also tried logistic regression. For logistic regression, the accuracy is about 75, which is much better than also random forest and naive Bayes. And the last one we tried is SVM, support vector machines, which we got accuracy for around 76. So this is the best machine learning model we can use in our case. SVM, it's not good for large number of records or data set with large number of records, SVM, but it's good for medium size or small size number of records. Okay, so this is all about our project here. We explored how we are going to do all the steps from starting by reading and cleaning the text and classifying the text, exploring the text to tell the machine learning model and check the accuracy that we have here with multiple metrics, precision, recall, and F1 score. Okay, so in our next step, okay, after this hands-on, which I mentioned before, that you are going to do to fetch some database, some data sets, and work with it directly with your hand. Okay, you can find all this. You can find all notebooks in GitHub. I can send the link to you, and you can work on it directly. Download the code and try to tune it to get better accuracy and with different data sets. Okay, so let's assume that you already did this practice. I have some comments and have some suggestions in order to make our machine learning modeling or predictions much better. Okay, so my revision, it may be some. I have some comments here. I marked it all with instructor code, instructor note. Okay. those are some suggestions and some corrections we may use and make use of it. You may want to put a documentation comment. Of course, we need to add some comments and documentation for each line of code to explain to other people. For especially if you are working on a team, you should put this documentation or comments. Also, you may want to explain the below data exploration section, describing your insights about data frame fields, data types. We can put also some documentation about each field here and why we have some null values here. What is the data type and what is the best data type. For example, why this is object. This one we can convert it to string, for example. So we can also do this. In the section of exploring categorical data, we need also to explain why we have this much of negative values. Maybe we should revise our data source or change it. Maybe it has some data bias. And the final result on the bottom line, we need to generalize, to have some better generalized data to our case in order to include all sentiments with يعني reasonable amount of variations. We should have many variations here. Second validation or suggestion we may use, we should pay attention to that drop duplicates is working. Why it's working in all columns here? We can make it work on just one column, or the number of columns that we need to remove duplicates, not on all records. We can also pay attention to this. Okay, and removing the handler, removing the user handler. Why we remove the handler? Because I see it's a good machine learning feature, and we can use this handler as a machine learning feature. We can separate it or create another column or another attribute and use it in our machine learning. It will give for sure it will increase our machine learning accuracy. For example, for any user, it's a pattern. يعني normally or usually you have on Twitter some friends. So this friend, I know for sure it's all the time he has negative comments and negative sentiment of his tweets. So for sure it will increase our machine learning accuracy to keep, if you want to keep it. يعني instructor node. Okay. Maybe you want to explore other vectorizer options other than TF-IDF. For sure, for text, TF-IDF is proof. يعني, during the last 2 years, it's one of the best vectorizers that we may use. But also we can use other vectorizers we can try and check the internet and the projects what are much better vectorizer we may use. يعني, for example, we may use neural network. We can feed our neural network create with different vectorizers other than the TF-IDF. Okay, you may want to put a documentation comment for previous. Okay, we back from start again. So I think this is all comments that I have here, and I hope you enjoyed the course and machine learning this. And one of the last thing I want you to do at home is this assignment is to download some data sets also and create the sentiment analysis on it with multiple classification. And what I mean multiple classification, you don't have only one classification for the tweet. Is it negative or positive? For some tweets you may find in the same tweet, same specific tweet, you can find negative comment and positive comment at the same time. So this is a kind of multiple label classification. Or multi-label classification. You can read about it and tell me our next lecture how we can do it. I hope you enjoyed the course, and thank you for listening and watching. See you later. Thank you.